Hello everyone, welcome to a video on variables and expressions. The goal of this video is to learn algebraic expressions like terms in simplest form, factors, products in exponential form, learn how to write verbal expressions from algebraic expressions, and write algebraic expressions from verbal expressions. So let's start with algebraic expressions like terms in simplest form. An algebraic expression is made up of terms and operations, such as addition or subtraction. A term may be a single number, we call that a constant, a single letter, we call that a variable, or a product or quotient of numbers in variables. So let's cover the four basic types of algebraic expressions. We have a monomial, that's an expression with only one term. For example, 3y is a monomial. A binomial is an expression with two terms, such as 5x plus 1. The way we know it is two terms is because the terms are separated by this plus, so 5x is one term and the 1 is another. A trinomial is an expression with three terms, such as 3y plus 5x plus 1. Again, the terms are being separated by this plus, so 3y is the first term, 5x is the second, and the 1 is the last one. Usually, if it's more than three terms, we just call them a polynomial. A polynomial is just an expression that has more than one term. Sometimes you're going to be asked to find like terms, and those are the terms whose variables and their exponents are the same. We'll do some examples of those in a second. And then an expression is said to be in its simplest form when it contains no like terms or parentheses. So let's try this example. State the name and parts of the following expression. Well, because this expression has three terms, 10x will be the first one, 7y is the second, and this 3 is the third one, then this is called a trinomial. There, we found the name. Let's now name the parts of this algebraic expression. The 10x, because it's the first one in the expression, is called a leading term. 10 is the leading coefficient. Remember, a coefficient is a number. And the x is just a variable. Remember, a variable is a letter. In the second term, the 7 is going to change its name from a leading coefficient to just a coefficient, because it's not in the first term. However, y doesn't change its name, it's still a variable. Finally, the 3, since it doesn't have a variable, this 3 is no longer called a coefficient. This is just a number, so it is just a constant. All right, almost painless. Let's go to the second example. Example 2 reads, write each expression in simplest terms. This means to simplify. So in 2a, moving from left to right, we notice that the first term is an m. It doesn't have an exponent, so we're going to look for another term that also has an m without the exponent. So this one, 5m, is a like term. So let's add them up. We have an m plus a 5m. Sometime to help us, we can actually write the number 1 in front of the m to help us add them up. So 1m plus 5m. Now this step can be skipped if you already know that having an m means that you have 1m. So the way that we combine these like terms, we add the numbers. So 1 plus 5 will be 6. And then we're just going to bring the variable. Let's continue to the next term. The next term is a negative 4p. We're going to look at the variable. This is a p without an exponent. So we look for another term that also has a p without an exponent, and that would be 6p. So then negative 4p plus 6p, we're going to combine the numbers, the coefficients. So negative 4 plus 6, different signs, so we subtract, so that will be a 2. And then don't forget to bring the variable. Continuing on, we're going to notice now that the third term is just a constant. There are no variables, so we're going to look for another constant to combine it with. In this case, is this minus 1. So we have a positive 4 minus 1, and that's going to give us a 3. So how do we write this? Well, because mathematicians like order, we're going to write them in alphabetical order. So we're going to do the 6m first, the 2p second, and then the 3. So 6m, the 2p, and the 3. Remember, these are 3 different terms, so we need to separate them using either pluses or minuses. Since they are all positives, we're going to put pluses around them, and this becomes our algebraic expression in simplest form. All right, you might want to try and pause this video and try 2b, and then come back and check if you got the same answer, okay? So here we go. We have 7x, and the like term will be negative 4x, so 7x minus 4x. 7 minus 4 will be 3, and we bring the variable. We try the next one. We have 3x squared. The like term will be 5x squared. So 3x squared plus 5x squared. We add the coefficients. 3 plus 5 is 8, and bring the variable. Don't forget the exponent. And finally, we have a single constant. Because there are no other constants, then we're just going to bring it and write it down. Now you might be asking, how do I write the answer for this one if they both have x's? Well, when that happens, we're going to write the x's in descending order. That means that we take the one with the highest exponent first and then go down from there. So then the simplest form of this expression will be the 8x squared, the 3x, and the 6. Remember to separate them using pluses or minuses. Since these are both positive, we're going to write pluses. All right, not bad. Let's move on to the next example. Let's move now to factors, products, and exponential form. In a multiplication expression, the quantities being multiplied are called factors, and the result is called a product. For any expression written like this, A is called a factor being multiplied by itself n times if n is a positive integer, a whole number. In an exponential expression, such as this one, A is also called the base and n is called the exponent or the power. Let's do an example to clarify what each of these definitions are stating. Something like this. If you have a 2 as a base and a 3 as an exponent, this can be expanded by writing the 2 being multiplied times itself 3 times, because that's the exponent. When we multiply 2 times 2 times 2, that's going to give us an 8. So these numbers being multiplied right here are called the factors, and the 8, the result, the answer that we get when we multiply them, that is called the product. Okay, let's go do an example. So example 3 is asking us to write the expression in exponential form, translate it into a verbal expression, and then find the product. All right, So this is 5 times 5 times 5. Because the 5 is being multiplied times itself 3 times, we can rewrite this in exponential form as a 5 to a power of 3, or an exponent of 3. So the 5 is called the base. The 3 is the exponent or power. And as a whole, this is an exponential form. Okay? Let's now translate this exponential form into a verbal expression. Let's do it over here. There are different ways to name this exponential form. We can call this 5 to the third, or we can call it 5 cubed, which is the most common one. All right, so we have rewritten this expression into exponential form, and from exponential form to a verbal expression. Let's now find the product. Remember, this 5 to the third came from 5 times 5 times 5. These are the factors. Let's multiply them 2 at a time. 5 times 5 is 25. Don't forget, we still have another one. And then 25 times 5 is 125. So this will become the product. Okay, let's go to the last section for this video. And that is about translating words into expressions. Notice the difference. On this example, we translated our exponential form to a verbal expression. We went from numbers to words. Now we're going to go backwards. We're going to translate words into expressions. So this is a very important skill to know in algebra. So this is only a small list on translating words into expressions. So for example, if you see the words sum of, that turns into addition, and so do all of these words. One that you have to be careful with is the word than, such as more than or greater than. Every time you see the word than, we're going to have to flip that expression. And I'll show you what I mean in an example. If you see the word difference, that's subtraction. Again, be careful with the word than. Product of, and all of these means multiplication, and quotient of, and all of these means division. Let's go try some examples using the list to translate words into expressions. Here we go. Example 4 is asking us to translate each word phrase into an algebraic expression. My recommendation is that you first go look for the keywords and then change it into either addition, subtraction, multiplication, or division. But remember, make sure that you are careful with the word than. So here we go. Letter A, we have the keywords more than. So more than means addition, but because the word than is there, these two are going to be swapped. So what does that mean? Instead of writing 3 plus x, we're going to write x plus 3. All righty. B, read 3 times a number plus 16. We have two keywords here. We have the word times, which means multiplication. Now, I'm going to use a little dot for multiplication here because I don't want to use the times symbol because it might be confused with the letter X. And then another keyword here is the word plus. Notice that then is not there, so we don't have to switch anything. So then this becomes 3 times a number. So 3 times a number plus 16. Now, you can leave the dot to mean multiplication, or you can just write 3n. Whenever we have a number and a letter together, that's already understood to be multiplication. So we're going to do that from now on. Let's try C. We have decrease. That's a minus. and times, of course, that means multiplication. So writing this from left to right, this will be 18 minus 3 times x. So 18 minus 3 times x, or better written as 18 minus 3x. One last example here. 5 times, that's the keyword, to the second power. Ooh, we just did that on exponential form, plus 16. So let's write it from left to right slowly. So 5 times z. They want us to send z to the second power, so that's an exponent of 2, and then add 16. Remember, we don't have to keep the times. We can just write the number and the letter next to each other, and we know that that means multiplication. Not bad. Thank you so much for watching, and I'll see you in the next one.